Okay, so should say that we're live right now. Waiting for the image to come in. All right, very cool. Let's see if I can hear myself. Yeah, okay, I hear the audio. All right, folks, welcome to another video on Alias. Today we are going to be making springs or helixes. Unfortunately, for some reason, there's no automated way to make helixes in the software. I don't really know why that is. Because we can make, like, spheres, squares, cones, but we can't make springs or helixes. And it's kind of weird because, springs are pretty important, when it comes to car design or motorcycle design or whatever. And it's pretty useful if you want to show like a shock absorber or, a strut or something. So, yeah, I thought today we're going to be making a spring, and because there's no real automated way to make a spring or helix in Alias, we kind of sort of have to hack things together. So let's go ahead, let's hop into the software, and let's get started. Alright guys, so we're in the software right now, and what I'm going to do is I am going to draw a basic curve. And I should mention before I draw the curve, the tool that we're going to be using principally to create our helix, there's technically two tools that we're going to be using. The first is going to be the rail tool, which is over here under the surfaces tab. And we're also going to be using the tubular offset tool, which is, there it is. It's under surfaces. If you click and hold the fillet flange tool, you'll see tubular offset. And just so you guys know, I'm going to be periodically checking the chat, so forgive me if you guys see like windows popping up and stuff like that, because I just want to stay in touch with you guys, making sure that everything's working. So as a matter of fact, I'm going to do a quick check right now. So okay, yeah, all right, everything's working. So just had to have a sip of coffee just now. Okay, so we're going to be using the tubular offset tool, and then we're also going to be using the rail tool. Okay, so when we create springs or helixes, we know that we have the overall width of the spring, and then we obviously have the length of the spring, and then we have the actual radius of the spring or the tube itself. Okay, so what we're going to do first is we're going to establish the length of the spring by drawing our first curve. Okay, so I'm going to hit Control and Alt, or as a matter of fact, I'm just going to press Alt so that we snap to the grid here, and I'm going to let go, and then with the right mouse button, I'm just going to drag vertically in the Z axis like so, and then I'm going to hit the space bar to tell the software that I'm finished with that curve, and then I'd like to start off with the next curve. I'm going to hit Control Alt, and I'm going to drag along this curve, and then I'm going to hit the middle mouse button or the scroll wheel. I'm going to go in the X direction like so, and that's going to describe the overall width of the spring or helix that we're making. Okay. I'm going to hit the space bar to confirm, and I'm just going to look around, and what I'm going to do is I'm going to add a little bit of an angle to our spring, okay? Because you know this bottom curve over here is, you know, the width of the spring, and then this top curve is the axis of the spring. It's the length of the spring. And so what I want to do is I'm going to put a bit of an angle to it. And to do that, I am going to hit Control Shift, like so, and then middle mouse button or the scroll wheel, and I'm going to hit Set Pivot. And what I'm going to do now is I'm going to hit Control and Alt, and what I'm going to be doing is I'm going to be taking, oh, I'm sorry, I have to select both curves. I have to select both curves first. Sorry about that. This curve and this curve. Control Shift, middle mouse button, Set Pivot. And what I'm going to be doing is I'm going to be changing the pivot points for both curves. Now, both curves, it appears that their pivot points are exactly where I want them, but just out of a matter of habit and good practice, I'm going to reset or move the pivot points exactly where I want, because that's just a habit that, you know, I got myself into, because you can never be too sure, you know, about where things are in Alias, and you just, you know, better to be safe than sorry. So go ahead, move the both pivot points to that point over there, and then we're going to hit Control Shift again, middle mouse button, and I'm going to go to Rotate. And now what I'm going to do now is I'm holding the middle mouse button. I'm just going to rotate both curves like so, and I'm going to get started on my rail. Okay, so Control Shift, pick nothing, and I'm going to double click the rail. First, a sip of coffee. Let me see if anybody's out there really quickly. Just hang on a sec. I'm just curious. Okay, cool. So we are back on. Now I have the rail tool opened up here, and by default it's set to by default it's set to a bi-rail. So what I'm going to do is we're not using a bi-rail, we're actually going to be using a monorail. It's really just you know, one surface. Okay, so we're going to hit it with a 1x1. It's monorail, and I'm going to select this as the generation curve, and then this as the rail curve. Okay, and I'm going to turn on metal just so that we can see what we're working with, and then I'm going to direct your attention to this function over here, the rotate X form. Okay, and this is where we're really going to be getting our screw. Okay, our helix. This is actually this tool isn't actually going to be making the helix, but it's going to be creating the data for which we can create a helix upon. Okay, so I'm going to go ahead and I'm going to try 360. Okay, because it's in degrees, and we can see that we've generated this helix here, and it looks very crude. Okay, I don't know why it looks so crude. Okay, that's better. Apparently, I guess there was a setting within the tool, because when I turn off explicit control, it doesn't look very good. And I'm also seeing... Okay, so we're just going to make sure we have explicit control turned on, because it just looks better with explicit control turned on. And you know, I want more turns in my spring. This is looking a little too coarse. So I'm gonna bump this up. Let's see. Okay, it's looking better. Let's try 1440. All right, and I'm gonna be a little picky here. I think it's a little too wide, the spring. So I'm gonna go over to Object Edit and Surface Edit. Was it Surface Edit or Object Edit? Yes, Object Edit, Extend. I'm gonna go to this curve over here, and I'm going to extend the curve backwards. Okay, why am I using this Extend tool? Because this Extend tool, what it's going to do is it's going to maintain the trajectory of the curve. Because if I were to just physically move this CV, I wouldn't get, true perpendicularity over here. So I'm just going to move, I'm going to shorten the curve here just so I get something a little bit more tame. And that looks better. And I'm going to hit Control Shift, pick nothing, query edit, bring up the monorail tool control. And I'm going to add more turns because I want, yeah, I like that better. Yeah, okay. So this isn't a spring. This is a helix of some sort, but it's not a spring. So what we're going to do now to generate our spring is we're going to direct our attention to the tubular offset tool. Okay? So the tubular offset tool is pretty self-explanatory. With this tool we can create tubes or pipes or what have you. And we have a bunch of different options, different settings. And right off the bat, I'm going to, I guess I'll use maybe 10 units or 15 units. I think this is millimeters. So 50 millimeter radius, or we could do, let's say, just do 25. It's a nice number. And I'm gonna get to the surface structure in a little bit, but I'm gonna leave this alone for now. So what I'm gonna do is I'm gonna have the tubular offset tool activated, and I'm gonna click the edge of my rail that I've created. It's gonna give me a couple options, and let's see. Well, let me get in closer. Maybe it needs more specificity. Okay, there we go. I'm going to click the edge of the rail, and you can see that it's asking us about, the orientation of the tube, and, if we're happy with what we see. And I'd say it looks pretty good. So I'm going to hit spacebar to confirm. And there we go. We have our tube that's just been built. It took a little longer than I thought it would. It might be because I have the tolerance set down so low. So this is for graphical representation. So when this number is really low, it basically forces your system to work harder to calculate things. But it looks visually better. We don't really need that visual accuracy, so we can have it at 0.1, and the tessellator we can put it to fast because we're modeling right now. We're not showing anything off. So that looks pretty good visually anyway. I'm going to hit Control Shift. I'm going to go to pick nothing, and I'm going to take a closer look at the spring surface itself to see how the data is, how the math is behind it. I'm just going to query edit and click, and I see over here it's the tubular offset tool has built a spring with, it looks like, one surface, which is good, which is nice, but we have 32 spans. Okay, so that's a span heavy object, and just if we can get a closer look, we can see. Let me see if I can. See if we turn everything off. Yeah, we definitely, we have spans in there. You can see, and they're not. It's all one surface. It hasn't been segmented or anything. So, I'm gonna turn colors back on. Control Shift, query, edit, and actually multiple surfaces was turned on, but it decided to just build it as one surface, which is interesting. So what I'm going to do is I'm going to switch the way the tubular offset tool has built this helix. I'm going to switch it to Bezier surfaces. Okay, and then it's going to give me the option to update. I'm going to click update. It's going to process. And look at that. If we look in the upper right corner of the screen here, we could see that the object that we've created is just one span, or what it's done is it should have created individual surface or surface tube sections, each of which being one span. And let's just confirm that. By query editing the helix and then turning on random color diagnostic shader here, and we can see that the data has changed. Okay, so we see now, which is very cool, that the data has changed and that each section here is just one span, two picked surfaces, one span. So now if we want to, we can delete the history of our spring, or actually, as a matter of fact, we can create a new layer, or I think it's fine the way it is. But before I move on here, I want to show you guys a way to potentially create springs, completely manually if you wanted to, at least in theory. And it's a little bit more involved, but I think you guys will learn a couple things, helpful things from working this way. Actually, first I just wanted to see if anything's going on. Okay. So, let's manually create. So what I want to show you guys now, we've used the tubular offset tool to create a spring, but I want to show you guys a more manual way to create a spring, because this process could come in handy in the future. And this will actually give you a little bit of an introduction to construction planes and how to create your own construction planes, because it's really important to create your own references in 3D space when you work with the software, and you'll find out that there are times when you absolutely need to create an independent construction plane that's not based off of what's going on in the world. Okay, the world within the software, the default world within the software. So let's go ahead and undo the data for the tubular offset tool, and instead what we're going to do is we're going to turn the metal on for the helix, the helixed rail surface here. And we're going to scroll up under the curve tab. I'm sorry, actually what we're going to do is we're going to go under the curve edit tab, and we're going to go to the fit curve tool. I'm going to double click that, and we can see here we're at 3 degrees. I'm going to bump it up to 5. Okay, and what we're going to do, what we're literally going to do is we're going to be creating, well, we're going to create at least one section of spring or tube, and we are, after I show you how to make, one section of a curve of a tube, you'll be able to make subsequent sections on your own. Bear in mind, this is a very labor-intensive process, and the tubular offset tool is going to solve like 90% of your problems. Okay, so this is really just, it kind of sort of is academic, but it's still important to know. It's still good to know. So so we have a rail surface here, and I'm just going to zoom in. And I'm going to click the edge of the surface, like so. And I have the deviation locator turned on over here. And I don't even need, I don't even need to see the locator. I can just see that the fit curve is absolutely not matching the edge whatsoever. So I'm just going to scale back. I'm going to go around the helix pretty far down, maybe down here, and I'm going to see how close we can get. And why have I decided to make the why have I decided to match a fit curve to the edge of the surface? Why did I decide to do that? I decided to do that because I need to create, if I'm creating a tube or a pipe or a section of a pipe, I need to create an axis, and that's actually what I'm doing now. I'm setting up the software so that the tubular offset tool, once I've established everything else, the tubular offset tool is going to be able to identify an axis, and it's going to be able to build off of that information. Okay, so using the fit curve, I can establish that reference, and I'm looking around now, and I see that the deviation is 0.016 of a millimeter. That means that I am deviating from the edge of this rail by 0.016. So from an engineering standpoint, we have tolerances, we have construction tolerances. Generally speaking, we try to make sure that everything is under 0.001, okay? So, we can increase the precision of the fit curve tool by adding degrees. And sometimes it works and sometimes it won't. In this case, it actually did work. Okay, so we're at 0009, which is under 0.001. Okay, I'm looking at the CV spacing, and it looks okay. It's a little awkward, but just for I'm just nitpicking right now. Just for right now, it's fine the way it is, considering that we're just trying to learn how to make basic springs, and we're not making cold hard engineering data right now. So go ahead, I'll exit out of the fit curve tool, and now we're going to create a construction plane. Why are we going to create a construction plane? We're going to create a construction plane because we need to create the base of our tube, the base of our pipe, which is going to act as a sort of springboard. Okay, no pun intended, but it's going to act as a sort of springboard, and it's going to also allow us to draw a circle on that construction plane which will set the radius or the actual width, you know, of our spring, of our tube. Okay, so to do that, what I like to use is the key point curve toolbox here, and I have this open by default always because I like to use, you know, mathematically precise, accurate lines in geometry. And I'm just gonna quickly make sure that I'm still running live here. Okay, very good. Just wanted to double check. So what I'm going to do is I'm going to so to get to this toolbox, okay, if you want to pop it up on your screen, it should be, you know, I've had this open for the longest time, so I don't, off the top of my head, it should be, yeah, over here, right in front of me, right here. This is the toolbox. It's under curve, the curves tab, under key point curve toolbox. Don't need this open. I'm gonna hit Control pick nothing because I don't know why this keeps popping up. But anyway, and what I'm going to do is I'm going to create lines that are perpendicular to the fit curve that we've just created. Okay. So under this line tangent tool, there should be line perpendicular, which is over here. I'm going to select that. We have some options down here. I don't usually bother with them, but you know, you can if you want. I don't have a reason to change any of these settings. So, and what we're going to do is we're going to use different views. Again, I'm working orthographically, not with perspective. This is orthographic. I'm going to work orthographically. Well, first I have to instruct the tool that I'm following the fit curve. So I'm going to hit Control, Alt, left mouse button. I'm going to go all the way backwards. I'm going to pull all the way backwards here to the base of the fit curve. Okay. And then orthographically, I'm going to hit left, the left view, okay, until it's green. And then I'm just going to pull. Okay, it's working laterally, which is fine. So that's fine. So just to give you a little bit more information as to what I'm doing right now, like I said before, I'm going to be creating a new construction plane, which is going to act as a springboard for the rest of the tube. Okay. In order to create a construction plane, I have to give the software 3 points. Okay, 3 points in 3D space to create the construction plane. Okay, I have to assign assign 3 points within the software to create the construction plane. I know this doesn't make too much sense right now because you're not seeing it in front of you, but it's going to make sense in a little bit. So right now we've just assigned the first point, or maybe the second point, if you will. That'll be the first point. This is our second point. I'm going to hit next. And I'm going to go into this view, and I'm going to cross my fingers that this is going to give me what I want for the next perpendicular curve. So I'm going to hit Control Alt. I'm going to drag down to the base here, and I'm going to go upwards. And it looks like it's giving me what I want. Okay, I'm going to hit next. I'm going to take a look here, and that looks pretty good. Yeah, that's going to work out. That should work out. Let me turn on X-ray. That should be good. Okay, so now what I'm going to do is I'm going to scroll down here on the palette under construction, the construction tab. Hit the construction tab, and there's going to be a button here for set construction plane, the set construction plane tool. I'm going to click that. Okay. And why didn't... I'm sorry, that was the wrong tool. That was the wrong tool. The set construction plane tool is to change the view, the way the relative world that you're working in. It's not actually setting the construction plane. To set the construction plane, you have to go to the plane tool, and we're going to hit the excuse me, we're going to press the 3-point button here. And you know, I'm just going to level with you here. I always forget the order in which we're supposed to assign the points for the construction plane. But I'm just going to wing it, and I'm going to hit fit curve. Okay. So what I've done is I've hit Control, Alt and Control. I've clicked the fit curve. I've selected the fit curve as a reference line, a reference axis, and it's blue, which is telling me that it's associating it with the z-axis. So this may or may not work. We're just going to cross our fingers and we're going to try anyway. So I'm going to drag it to the base here, and then I'm going to let go of Control and Alt. I'm going to hit Alt and Shift so that we can turn the view, and then Alt and Control, and I'm going to click the secondary axis, which is over here. Okay, and it's looking like it's associating that with green. Okay, which would be Y, and then the last one is, it looks like it's going to be associating that with X. So that's looking okay. I think that's looking pretty well lined up. Okay, I'll just hit next plane, pick nothing, Control Shift, pick nothing. And what I'm going to do, okay, now I'm going to, just bear with me a sec, I'm going to need to go back to, I just want to see some of what's going on with the stream here, making sure, you know, everything is working periodically here. Let's just take a look. Okay, very nice. Everything looks good. Okay, all right. All right, pardon me. Okay, very good. So, what I'm going to do is I want to introduce you guys to, so in Alias we have the general world, or the default world, okay? And the default world is linked to the view cube, which is over here, okay? And it works pretty good for most of our needs, okay? But when we're working with construction planes, things can get a little bit weird, okay? And it's got to be that way because when we're working with custom construction planes, you know, everything becomes relative. Our viewpoint, our perspective becomes relative to that construction plane that we set, okay? So once we've established a construction plane like we've just done over here, we want to work with it, and we want to associate ourselves with it. So what we're going to do is we're going to hit Control Shift, left mouse button, pick object, because it's an object. It's not a curve, it's not a surface, it's not a line, you know, it's not a span, it's an object. We're just going to click it just like that. Okay. And then we're going to move our cursor over under the construction tab, and we're going to hit set construction plane, like so. And you'll notice that the view cube has changed. Okay, it looks all weird now. Why does it look weird? It looks weird because it's working in reference, relatively speaking, to the plane that we've just created, okay? And the plane that we've just created is built to match the axis of the fit curve tool that that we built previously. Okay, so this is looking pretty good. And now what we're going to do is we are going to build a circle. Okay, so we have a few different ways of making a couple different ways really of making circles. We can make I call it a casual circle. You know, this is a casual circle. We can make a circle this way, or we can make a circle, a geometrically precise circle, if you will. Both are fine, you know, depending on your needs. So we'll just, I guess we'll work with the geometric circle for right now, 6 degrees, 1 span. And actually, just to compare the parameters of both, we see with the geometric circle we have 6 degrees with 1 span. The casual circle, wow, okay. A casual circle is 5 degrees with 12 spans. Well, you know which side I'm leaning towards. You know, I'm leaning towards, you know, a low span, more geometric, mathematically accurate circle. So let's go ahead and work with that. Okay, so I'm going to go click circle. And to be totally honest, I don't know how the software is going to react to this. But we're going to try it anyway. Okay, great. So I'm holding Control and Alt, and Alias has recognized it's either recognized the edge of our surface, or it's recognizing the fit curve. Either way, it shouldn't really be a concern for us. So I'm just going to go ahead and I'm going to drag this axis point here all the way to the base of either the fit curve or the rail surface, and I'm going to let go. And you'll see that we've got some guidelines that have popped up, you know, and they have a place. I find that they get in the way fairly often, but you know, some people have a use for them. And I just got to reorient myself here because you know, this is what I was trying to explain, that things can get a little weird when we create custom construction plans. So we kind of get a little disoriented sometimes. So now that I've just gotten myself reoriented, we can go ahead now. We can establish the radius of the circle that we've just built. But first, we're going to have a sip of coffee. All right. So I'm going to try to get in front of this plane, and I'm just going to click because we could see here, use mouse or enter point of circle. So we can manually enter the radius if we want. I'm just going to click. We're going to do a visual. Let's see if it works. And it does. Wow. Today is my lucky day. Very cool. So let's see. It should be in millimeters. So we did 25 millimeters before. We're going to bump it up to, let's do another 25 millimeters. And actually, as a matter of fact, shoot. Okay. It looks like, you know, I didn't. Maybe can we scale this up? We can. I'm actually going to rebuild the circle because I want to enter a precise figure for the circle. So I'm going to delete it. I'm sorry, guys. I'm going to delete it. We're going to start this again. And I'm going to delete, just in case, I'm going to delete guidelines. I don't think there are any, but okay, good. We're going to rebuild. We're going to create a new circle all over again. And I'm just going to drag to that point. And I'm just going to type in, 25, and that should work. 25, enter, and there we go. Okay, great. So we have a circle, a geometrically accurate circle that's just been built, 25 millimeters, which should match the tubular offset parameters that we've established earlier. And yeah, okay, I just hit enter just in case. So now we have our circle, okay? And we don't have to reference this construction plane anymore, okay? This is just confusing us. We don't have to, again, when we're working with custom construction planes, things get kind of weird, it kind of feels like you're floating in outer space, and I'm finding that I'm always like reorienting myself all the time when I'm working with custom construction planes. So let's go ahead, let's get back to the default world here. And I think toggle should work. Yeah, toggle works, but there's also, okay, I think that probably switches, because I remember I used to use toggle switches between the construction plane and the world axis. Axes. Yeah, anyway, so toggle construction plane, that's going to go back and forth between whatever was your last construction plane that you've created versus the default world, okay? So in case of emergency, okay, go to the construction tab and hit toggle construction plane, okay? So let's move ahead. So we've established our axis with this fit curve, and we have a nice circle sitting directly on the base point of our fit curve over here, and it's oriented, it should be oriented perfectly, because we've established a 3-point construction plane using perpendicular lines, so it's hard to negotiate with that, okay? I mean, I'm just being real here. So let's go ahead and let's build ourselves a tubular offset based off of that data. So 25, everything's 0. We shouldn't need Bezier surfaces for this, and it should work with a single surface. We'll hit next. We'll click the circle. I don't know why it's orienting the circle that way, but I'm going to go ahead and I'm going to click the fit curve. Okay, so I don't know why. Oh, you know what? I think I know what's going on here. Okay, I generated more data than I needed to. So in this case, we could probably work with the extrude. The extrude tool should work. Or let's try the extrude along the fit curve. Extrude pivot. Okay. So it turns out I may have created more geometry than I needed to. Tubular flange, we don't need that. Okay. So we can use the tubular offset. We could do, we could just stick to the regular fit curve and build that. And we have one section, you'll see it's a 5/7, one single span, and it falls, and you'll see it falls precisely on the circle that we've created, the geometrically accurate circle. But if memory serves, there should be a way. It's the profile tool. It should be that's what it was. Okay, I was confusing. Okay, I'm sorry guys. I was mixing up tools here. between the extrude and the profile. So again, we could go ahead and we could just use the fit curve we've created to manually create sections of tube, okay, like I've just showed you, a couple seconds ago. Or we can use the profile tool, okay. I don't normally use the profile tool so much, but we see here it says guide curve, and let's keep it at single surface. Let's experiment with this. Okay, select curves or surface curves. Okay, this should work. We'll hit accept to confirm that this is the the profile, I mean, technically we're extruding from a curve, so I wasn't wrong, but whatever. Okay, and then I'm going to click the curve here. This is going to be the guide curve, fit curve. I'm going to done. Okay, so I got to redo this again. Okay, circle, done, and then it wants a rail path, which is our fit curve. Accept. Okay, so it wants another one now. So let's see. Natural. Okay, so we're gonna fit curve, done. Okay, well, great. So it worked. It worked. This is a 6x6. I wasn't talking because I was thinking. It's hard for me to think and talk at the same time sometimes. Ha ha ha. Okay, so it's pretty obvious that I don't normally use the profile tool that often, but intuition is telling me profile orientation. Okay, we'll just keep it to natural, just so that I know here. Natural. We'll click the circle, select curves. So it says here, select curves or surface curves for profile set selection. Click done to select the rail path. This is the rail path. And if I hit build, okay. Okay, so this is another option. We can use the profile tool to establish, like I said, a circle here. And then we use the fit curve to establish the axis. And we see that it's a 6x6 single span. We can go ahead and verify it's one surface by using colors here. And then just to study the object a bit better, we'll turn on X-ray for that object, and then we're going to use the tubular offset tool, and we're going to build a tubular offset with that fit curve. We'll hit with 25 millimeters tube build. We get a 5.7. Okay, and if we turn on, we're doing research here. Okay, guys, we're doing research. Okay, we see that they line up on top of each other. Okay, so the way the surfaces, the way the tubes are interacting, it's telling me that the data is on point here. Okay, and then what we're going to do now is we're going to do a tubular offset for the entirety of the rail tool. So I'm going to hit the edge of the rail that the edge of the rail surface that we've created. Hit build. Hopefully it doesn't crash. Okay, very nice. I'm going to hit Bezier surface, multiple surfaces. I'm going to hit multiple surfaces, Bezier surfaces, update. Okay. Okay, we have individual sections here. Let's check the individual sections. Okay, that's looking like 1, 2, 3, 5. That's a 5. 5 by 1, 2, 3, 4. Looks like a 5 by... No, it's a 7. Okay. So there are 5 by 7 sections, which is good. But interestingly enough, I'm going to hit Alt-O to get rid of the CVs on the amber section there. Okay. I'm going to go in to... I'm going to zoom in on the profile that... So I'm going to turn on X-ray again, and I'm going to click the profile that we've created. I'm going to turn on color for that. And we see that it's a 6 by 6. Okay, I'm going to turn on CVs, and the math is a little different for this one. It's a little less. 6 by 6 compared to 5 by 7. Interesting. It's interesting sometimes to see how Alias decides to calculate certain things. So it's really just a matter of preference. Anyway, guys, sorry for the confusion, but basically in this stream, is basically to show you guys the different ways we can create tubes. I know it may have been a little bit fast. Let me just double check the stream here, just really quick. Wow, very cool. Okay, so yeah, I think that's pretty much a good explanation of all the different, or the few different ways we can create springs. Again, I'm just going to hit Alt-O. So just like I showed you, we create a construction plane, an infinite plane down here, and then we establish the XYZ axis of that plane using perpendicular lines, and we make sure we have a good cup of coffee to go along with our Alias model, or modeling session, I should say. And once we've established good, clean geometry, everything is 0009, we can have some fun, with either the profile tool. We can use that. This looks like a sweep tool. This is interesting, creates a surface by sweeping out the movements of an animated curve through time, as if the animated curve was leaving a surface. Interesting. I've never used this tool before. If any of you have used this tool before, let me know how this works, because that's pretty cool. Didn't know you can have an animated curve. Okay, there's the extrude tool. But the extrude tool, let's see. No, I was right originally. I was correct. I was originally correct. So I don't know why it wasn't working for me, the extrude tool. Okay. Or maybe I did use it and I ended up correct. I ended up right. Okay, so there's the extrude tool that we can use to create a pipe or a spring or helix. So yeah, there's the profile, tubular offset, and extrude. And yeah, and so once you create your curve or your tube, obviously you don't need the surface anymore. You can delete it. So I'm just gonna go ahead. Actually, what I'm gonna do is I'm gonna create a new layer. I'm gonna call it just like just in case. Okay, just in case I need the data for later on. What I'm gonna do is I'm gonna query edit. I'm going to pick the object, and I'm going to assign it on just in case, the just in case layer. Turn that off, close this window. And then, just to be fancy, I'm going to go ahead and I'm going to turn on visualization 3, toggle the model, and we have a very nice looking spring. Oh, and I forgot to mention, you know, obviously you don't want to have hollow springs, right? So what we're going to do, just to cap off these springs, the planer tool, very simple, to the point tool. We're going to just click the outer edge of our spring with the planer tool. We'll hit go, and ta-da, we've capped it off. See? You might be asking, why, you know, is like the planer tool doing some kind of like magic stuff? Is it doing anything that, you know, we can't do, you know, in Alias? The answer is no. It's not a magical tool. I mean, it seems magical, but it's not really magical, because all it's really doing, again, like, because in my past video, my past tutorial, I explained that, you know, 80 to 90% of the functions in Alias are based off of curves and surfaces, and really that's it. And the planer tool, you know, is no exception, because what it's doing is it's building a square surface. Actually, I'll just show you. It's building a square surface, and it's just trimming it out. It's doing a circular trim. And as a matter of fact, I can click the surface, I can hit delete history, I can confirm that, and then I can go to the trim tool here under surface edit, trim, click and hold, go to untrim, okay, and look what happens. See? It's just a square, you know? And it's what it's doing is it's just projecting, you know, the edge of the tube. It's just projecting the edge of the tube onto a new square surface, and then it's just using curve on surface data, okay? Just using curve on surface data to create a closed, you know, a closed feature, basically, a closed trimmable feature, okay, that can be trimmed out, and there you go, you know. And then we'll, you know, so that's that. I'm gonna hit Alt O to get rid of the CVs, and then just for good measure, I'm gonna go down here. I'm gonna turn color back on. I'm gonna select our other tubes here. I'm gonna, you know what I'm gonna do is I'm gonna, what happens if I do this? Okay, no, I didn't want to do that. I didn't want to do that, so why did it do that? Surface, click surface, assign, I'm going to assign it to the default layer, very nice. Turn everything off. Okay, X-ray, I'm going to turn X-ray on, pick surface, I'm going to pick the tube, I'm going to put that on just in case, assign, turn that off. I'm going to pick this other tube over here, I'm going to assign that to just in case. So all we should have right now is our tubular offset. And now what I'm going to do, I'm going to do another planer here. Another planer. There's planer. Click the, I don't want to click the circle. I could click the circle if I want, but just because I want to make some references to the existing tubular piece. So I'm going to click the edge of the tubular, the edge. I'm going to click the edge of the surface of the tube. Okay, I'm going to click that and hit spacebar. All right, that looks good. And what I'm going to do is I'm going to go up to the top here, and this is a little bit of extra credit. Okay, you guys, this is a little bit of extra credit, but why not? Okay, why not? I'm going to create a fillet because, like, you know, in the real world, you can't have, you know, perfectly perfect 90-degree edge like this. You just can't do it. So I'm going to create a fillet, surface fillet. I'm going to leave everything on default. Okay, and just as a precaution, I'm going to save my work. Just as a precaution, save as. I know the screen might be off for you guys right now, just bear with me. I'm just gonna save that. Alright, I'm gonna turn the screen on again. You guys should be with me. Are you guys with me? You guys should be with me. I think so. Okay. Yes, you guys are with me. Okay. So, I've just saved my work. I'm going to make a default fillet around this edge. Alright, might be wondering, what's a fillet? What is a fillet? A fillet is like, it's like a rounded piece of it's like an edge, basically. It's a rounded edge, okay? So what we're doing is we're making, a mathematically accurate engineered edge. Manufactured, machined edge, okay? And this tool accelerates, like I've said before, it accelerates, what would otherwise be, a very labor-intensive process. So I'm going to go ahead, and actually, maybe in the future, I'll create other videos on the fillet tool just to give you guys a more in-depth look as to how the fillet tool works and all the features of the fillet tool. But for right now, let's just take it for face value and just, just watch and enjoy, the, what's in front of you. So let's go ahead and move forward. So I'm going to click this as one side, and I'm going to click this as another side for the fillet. 5 millimeters should be good. I really hope it doesn't crash. I really hope. I'm going to hit build. Okay, it didn't trim out the fillet. Why did it not trim it out? Probably because I want everything edged up. Still didn't do it. Okay, so we're gonna manually trim. That's fine. I'm not worried. Let's see if I can change maybe some of the settings here. Okay, let's do this. Continuity check update. Let's see where the problem is. No, everything looks sealed up, so I don't know why it would. Alright, let's manually trim and see what happens. It's not registering. Why wouldn't it register? There's no reason why this shouldn't be working here. Okay. So, what I'm going to do then is I'm going to do a little bit of a workaround here. Man, I tell you, the fillet tool, it's really hit or miss whether the fillet tool is going to work. Okay, let's do interior edge line. Maybe this will work. That didn't do it either. Okay, let's try, you know what, maybe this will do it? Why aren't we getting... Okay, that's fine. So, what we're going to do is I'm going to go back to default here. I'm just going to... Great. And we're going to do... We'll do it this way. And what I'm going to do is I'm going to do a bit of a hack here. I'm going to create a planer. Okay, I'm going to create a planer on this back edge over here of the fillet. And I'm going to untrim that planer. And with that untrimmed surface, I'm going to use it as kind of like a slicing tool that's going to slice through magenta over here. All right. So like a handy little way. You know, in Alias, you're always looking for workarounds and hacks and stuff like that. And it's just kind of the nature of the beast, you know. So going back to X-ray mode now. And I'm going to move over to planar. I'm going to hit the base of that fillet. Okay, hit go. And you'll see that we have our planar. I'm going to untrim. And as a matter of fact, I'm going to get rid of the curve on surface. So I'm going to hit Control Shift, pick curve on surface, left mouse button. I'm going to delete that. Okay. And all I'm going to do now is I'm going to intersect blue with green. Okay. I'm going to go down to the tab here, Surface Edit tab. Under the project tool, click and hold, Isect, which is short for intersect. I'm going to click green. I'm going to click, well, I'm going to hit spacebar for go, and then I'm going to click blue. And it should create a curve on surface which is intersecting green. Okay. And all I'm going to do is I'm going to select the trim tool, and I'm going to double click green. We see that we have the cyan plus sign, which is indicating that Alias has identified a trimmable area, but just to verify, to make sure that we have a closed profile, a closed trim, I'm going to go back to X-ray. I'm going to go back to the trim tool. I'm going to click the tube. I'm going to click it again. And I'm going to look for these tiny little lime green X's here, plus signs. And I'm going to look to see if there are any red ones, or there are no red ones. So that means it's airtight, watertight. We have a tight seal. So I'm going to go ahead and I'm going to hit keep, or I'm going to press the space bar. And that should work. I'm going to turn on metal. And it didn't work. Why didn't it work? Oh. Okay, so we didn't get enough of an intersection, I guess. Pick COS. Alright, I need to get rid of all the COSs. Alright, what I'm going to do is to really make sure that we have, to make sure we're completely intersecting the surface. I'm going to extend all four edges here. Oops. Okay, I'm going to go back to intersect. Click one surface, click the other surface, hit go. And then I'm going to trim. Okay. Now I'm not getting any. I'm not getting anything. Oh God. You gotta love it, man. You gotta love it. Let's try this way. Maybe we're intersecting incorrectly. One. Okay, that should work. This should work. Okay. But for some reason, okay. So the curve on surface isn't intersecting. Okay, so it's not intersecting correctly. So So what we're going to do is we're going to try to project a normal. Try it that way. Intersect, project, hit it with the normal. Project onto here, go. Let's see if that works. Alright, we have gaps. Okay, so object display. I'm gonna get a little bit more aggressive here, guys. Oh, hide unselected, and we're really okay. So, untrim. Okay, we got these COSs here that they're just messing us up. Okay. Object display visible. Let's do another intersect one. Okay, that should be clean now. And there we go. Oh, guys, I gotta tell you, that's just the nature of the beast, you know. What? Why did it disappear like that? Okay, so guys, the problem that we were having was that the fillet tool, either the fillet tool, probably the fillet tool, and the planer tool, between the two tools, we were getting curves on surfaces which were projecting onto the tubular offset, which was messing up our trim function, and it was giving us problems, and things just weren't trimming properly. So what I did was I isolated the tubular offset object. I isolated it, untrimmed it, took a look at the curves on surfaces. I deleted the curves on surfaces, and I recreated new curves on surfaces using the intersect tool with the untrimmed planar surface that we created. Take note, however, that while in the process of deleting the curve on surface data, I think we've deleted history, construction history for our fillet, okay? And I'm just going to verify that right now. And we have. Okay, so we can't edit the parameters right now for our fillet. And the reason why it's a bit of a bummer is because if we wanted to reduce our spans and stuff here, there would be some functions and ways for us to do that. So there are ways that we can still do everything that we did without deleting construction history. I just deleted construction history because I want it to be fast. If you go to the surface fillet tool, under control options, you can have it automatically trim, you can have it project curves onto surfaces, or you can just turn everything off, in which case you can build your own curve on surface data and do things your way. So we'll go ahead and hit next. Go ahead and I'll delete this. Yes, I know there's construction history, that's fine. You guys might notice that there's a gap here, right? Huh? You think I forgot about that? I didn't forget about that. I would never forget about that, So, there's different ways that we can fill the gap. We can try and extend, an unmerged extension, which I think should be enough for our needs. It should be enough. Good enough. It's really small, really tiny. Okay. And, didn't. Okay. Well, I gotta fix this gap now, right? Okay. So we can go to the align tool, G2 align, boom, boom, edge align's fine, accept, delete locators. All right, let's check our math. You know, we don't need G2 curvature as long as we're meeting like maybe G1, I guess. Toggle the model. Okay, so we're out of position. We're not off by much. We're not off by much. You know, for visualization purposes, you know, this fillet's fine. But, you know, if you really want it to work to the Class A level, you can go in, you can manually manipulate the CVs, realign things, whatnot, what have you. So yeah, I'm gonna go ahead and I'm going to save our work, hit Alt-O, delete locators, and I'm gonna leave it at that. I'm gonna save it again, actually. So let's go ahead now. Let me see. Should be working. What's going on? Video capture. Okay. I think some hotkeys weren't working accurately or properly for some reason. Okay, guys. So that explains how to create a spring or helix in Alias using NURBs math. You know, it's important that, you know, when we create, you know, things that are going to be manufactured, that we, you know, we make things with mathematical accuracy and stuff like that. And that they're, you know, the tubes or the pipes that we make are as smooth as possible. Because, you know, if you were making like a car part, let's say, you know, like an exhaust manifold or an air intake, you know, you don't really want to have kinks. You know, if it was like something that were to be 3D printed, you know, you would want a really smooth surface. You know, if it's like say like for a cylinder head, you know, you have your ports, you know, in the cylinder head. You want really nice smooth surfaces, you know, going into your combustion chamber and into your cylinders, you know, because that's how air works, you know, that's how physics work. You know, if you have a lot of kinks everywhere, a lot of bends, you know, you're gonna get less performance. Okay, guys, so that's it for the stream today. If you guys have any questions, feel free to send me a message, comments, whatever you want. If there's anything specific you want to see, let me know. Basically, just let me know. And till we meet again. See ya.